All right, problem number 4, it's a very tricky one. This is a combination of conservation of energy and also reviewing of projectile motion. So we have a ski jumper that starts 50 meters above the ground, at 10 meters above the level ground, flies off at 45 degrees from the trampoline. So I took the liberty of drawing this right here. We are going to first figure out with what speed flies off of here. So this is technically the final for the 40 meters that she travels down a frictionless track. Since the track is frictionless, I can say that UG initial, and I will take that as a 40, even though they say 50 meters above the ground. That means it's 40 meters of the level from which she flies off. That gravitational potential energy initial equals kinetic energy final, where this is going to be mgh initial, 40 meters, equals to mv final, which we are after, squared, that's our question mark, divided by 2. Cancel mass, that's why they didn't even bother giving us her mass. If there's no friction, there's no need for mass, providing there's no spring. Then we have v final is a root of 2gh, 28 exactly meters per second. So that answers question number A. B, what is the maximum altitude? Because she flies off at 45 degrees, we know that she will keep her horizontal velocity, but will lose her vertical velocity. So I can say kinetic energy Y turns into UG, and then kinetic energy X is constant. It remains constant. MV cosine of 45 squared divided by 2 turn into MGH final for her maximum altitude, and then H final, also known as H max in this question, 30 meters. Total displacement for her is going to be, she leaves it at 10 meters, goes all the way up to 30, then falls back down. The change in y for her is negative 10 meters. And then I can find the change in time by graphing this equation. Negative 10 equals 28 cos of 45 times change in t minus 4.9 times change in t squared. This is change in y equals v initial y times change in t plus 1/2 acceleration g times t squared. So once you graph that, you should get a positive answer and a negative answer. Right? So I have I got negative 45 and I got 4.49 seconds. From there, t equals 4.49 seconds, 19.8 times 4.49 seconds should give me the horizontal displacement that it reaches, and it's 88.9 meters. That's the answer to C. So there we go. It's a beautiful problem, which is a true AP problem because you have to remember conservation of energy and projectile motion. I hope everything was clear. And if you have any questions, please let me know. Thank you for watching.